Saifullah, Alan, Farad, am I audible?
Yes.
Let's start. Last time we discussed dual nature. Now, d Broglie wavelength associated with the uncharged particle, that is neutron. So for neutron, the d Broglie wavelength is 0.286 10 to the minus 10 meters. Energy must be in electron volt. This is the formula you have to remember. All right. Energy of a thermal neutron or gas molecule at ordinary temperature. K is a Boltzmann's constant. So lambda associated with it is H is a Planck's constant over under root 3m kt. K is a Boltzmann's constant. This is the energy of a thermal neutron or gas molecule. Now, characteristic of matter waves first. The matter waves are not electromagnetic waves in nature. Technically, they are mechanical. What do you mean by electromagnetic waves, Alan? Alan, what do you mean by electromagnetic waves? Alan, what do you mean by electromagnetic waves?
So it's a sinusoidal wave that has inducing electric and magnetic fields.
As well as accelerated charge particle. It also radiates energy. And mechanical waves. Saifullah, what are mechanical waves? The waves which are produced in string are known as mechanical waves. So matter waves are neither in electromagnetic nor in mechanical nature. So it independent of charge. Phase velocity of the matter waves is greater than the speed. What do you mean phase velocity? Phase velocity means the speed of the wave in a given medium. Now, number of d Broglie wavelength associated with n orbital electron is n. Now try this question. So these are the characteristics. First, that they are not electromagnetic in nature. They are not mechanical waves. They are independent of charge. The phase velocity is greater than the speed of the light, and the number of d Broglie wavelength associated with nth orbital electron is n. Now try this question.
Sir, can you show the formulas?
That's it. K is a Boltzmann's constant. T is a temperature. Today we will complete the atoms, and tomorrow we will start nuclei. 7th, on 7th you have exam. Fast.
Sir, what is in bracket?
In electron volt. Done.
Yes, sir.
These are the characteristics. Try this question. Not very difficult. 2 to 3 minutes. The deep wavelength of a neutron in thermal equilibrium with heavy water temperature T and mass m is. Deep wavelength we have to calculate. 3 minutes, write your answer in chat box then. Fast. Write your answer in chat box in just 3 minutes. Then we will start atoms. Rest of you write the answer fast. Alan, Saifullah, Eva, Mamuna, write your answer. Now, how to do? Since we know, since I told you lambda equals to h over 2m k, this is de Broglie wavelength for any particle. What is kinetic energy? So kinetic energy is 3 over 2. This is kinetic energy. K T. K is Boltzmann constant. So kinetic energy KT. Substitute the value lambda equals to now B is the answer. Very easy question. B. So kinetic energy is 3 over 2 KT. So find the D. And there is an experiment conducted by Division and German, in which they showed, means de Broglie said, when a particle is in motion, it exhibits wave-like character. Fine. So Division and German, there were two scientists, they conducted an experiment, and in that experiment, they found de Broglie was correct. It means when an object, when a particle, irrespective of the charge, when a particle is in motion, it also exhibits wave-like character. Fine. So it was an experiment. Now Rutherford atom, Rutherford model. Rutherford model. Alan, what is Rutherford model? He conducted an experiment with his two assistants, Giger and Martian. Hello, Alan.
Yes, sir.
Okay, what is Rutherford model of alpha
So,
particle?
so it's the alpha particle model where they found out where the nucleus is.
So Rutherford with his two assistants, he conducted an experiment in which he projected alpha particles on a gold foil, in which he concluded that most of the alpha particles, Yes. Am I audible? Okay. Rutherford and with his two assistants, Jeter and Merson, conducted an experiment in which he concluded that on a gold foil, he took a radioactive substance as polonium. He kept it in a copper, in a lead, in a what do you call lead shell. Fine. So he concluded that most of the alpha particles passed straight away. Some of the alpha particles deflected more than at an angle more than 90 degree. Few alpha particles return back. This is number of particles, and the number of alpha particles inversely proportional to the sine raised to power theta. It means the number of scattered particles inversely proportional to the angle. This is scattering angle. So if we increase the scattering angle, the number of particles will be less. This is a graph for Rutherford. Distance of closest approach. That this is a nucleus. This is an alpha particle. So distance of closest approach means the minimum distance by which it retraces its path is known as distance of closest approach. For example, let it be an alpha particle. It is moving with velocity v towards the nucleus. Let it be r naught is the distance at which it retraces its path. That distance is known as distance of closest approach. So the minimum distance from the nucleus up to which the alpha particle approaches is called distance of closest approach. Now, initially it possesses kinetic energy, and as the alpha particle reaches at this point, let it be P. So the total energy, the entire energy will change into potential energy of the system. So initially the alpha particle possesses half mv square. At this point, the total energy will be potential energy, that is 1 over 4 epsilon naught ZE bracket 2 E over R naught. This is the potential energy of the system. Now, after solving this, you will get R naught equals to 4K, where K is the 1 over 4 epsilon, Z is the charge of the atom, E is the charge on electron, M is the mass, and V is the velocity. Impact parameter. This is an impact parameter. Impact parameter. So the perpendicular distance of the velocity, that is, this is the velocity. So perpendicular distance, that is V, perpendicular distance of the velocity vector from the center of the nucleus, this center of the nucleus. Fine. When it is far away from it, this B is known as impact parameter. Its formula is 1 over 4 epsilon ZE square cot theta over 2 over half mv square. This is the formula to calculate the impact parameter. Impact parameter, basically, it is the perpendicular distance from the center of the nucleus. Perpendicular distance of the velocity vector. Now try this question. You have to use this formula. Fast.
Sir, can you show the formulas, please?
This is the formula to calculate the closest distance of closest approach. So what is distance of closest approach? The minimum distance by which the alpha particle retraces its path. That distance is known as distance of closest approach. Z is the charge on nucleus and 2 is the charge on alpha particles. That it is approaching towards the nucleus with the velocity v. And what is Rutherford model? Rutherford with his two assistants, Jeter and Merson, conducted an experiment in which he projected a fine beam of alpha particle on the gold foil. Fine. He took a radioactive substance, that is polonium, and he kept it within the lead block. And he concluded that most of the alpha particles pass straight. Some alpha particles are deflected at an angle more than 90 degree. Very few alpha particles retrace their path. Fine. So when the alpha particles pass straight, then he concluded that most of the atom is empty. Fine. He also said that the electron moves in a circular path around the nucleus in a similar way as the planets revolve around the sun. And nucleus is positively charged, and the entire charge is concentrated at the center in the nucleus. All right.
Yes, sir.
Does anyone have problem?
No, sir.
Okay, fine. Written, Alan, done.
Yes, sir.
Impact parameter formula. This is the formula for impact parameter. So what is impact parameter? Impact parameter basically the perpendicular distance from the center of the nucleus of velocity vector. That is V is the impact parameter. This is a nucleus. Let it be this an alpha particle. Just note down, then we will discuss this question. Pass, everyone, pass. Done, Alan.
Yes, sir.
Now try this question and write your answer in chat box. Fast. 2 minutes. Very easy. Use the above formula to calculate the answer. What will be the correct angle for the scattering for an impact parameter B equals to 0? Impact meter is given. Impact parameter is given, that is B is 0. We have to calculate the theta. What will be the correct for alpha particle? Put in the given formula, you get the answer very easily. Pass, everyone. Write your answer in chat box. E. E. Farhat, write your answer. Mamuna, Hiba, Hanifa, everyone. Write your answer in chat box. Speed up. D. Look, the formula is 1/4 epsilon Z E square cot theta over 2 half mv square. It is given that V is 0. So obviously 1/4 epsilon Z E square, this is not equal to 0. So cot theta over 2, cot theta over 2 is 0. It means that is 90. Theta equals to 1. Is it clear to everyone? Done? This is most important, Bohr's atomic model. Actually, Bohr, he proposed the model for the hydrogen atom, fine, which is applicable to lighter atoms. Bohr model of an atom is applicable only in case if an atom contains just a single electron. All right, like hydrogen, deuterium, helium, positive ion, singly ionized, lithium, doubly ionized. So he proposed the model for lighter atoms, fine, in which single electron revolves around the stationary nucleus, a positive charge, that's it, called hydrogen-like atom, that is hydrogen, deuterium, He plus ionized ion, lithium doubly ionized. Hydrogen Bohr model of an atom is applicable to single electron. Now Bohr's postulates first an electron in an atom can move around the nucleus in a certain circular orbit. They are stable orbits without emitting, because the Rutherford said when electron moves in a circular path, so there is an acceleration, so it radiates energy. According to Rutherford, the orbits are not circular, they are spiral. Fine. So Bohr said that when electron moves in a circular orbit and electron doesn't emit any energy, so the electron moves in a stable orbit called stationary orbits. Second, electrons can revolve only in those orbits in which their angular momentum is the multiple of h over 2 pi. This is the angular momentum. Electrons only move in those orbits in which the angular momentum is a multiple of h by 2 pi, where n is the principal quantum number. Frequency condition: when electron jumps from higher to lower orbit or higher energy state to lower energy state, then it radiates energy in the form of photons. While when it jumps from lower to higher, then it gains energy. So this frequency condition, h nu equals to E2 minus E1. This formula you have to remember. Energy in the higher orbit, energy in the lower orbit. Now Bohr's atomic model of an hydrogen atom. So it is an hydrogen atom. An electron is revolving around the nucleus. So there will be two forces. First is centripetal force. Let it be R is the radius. mv square over R must be equals to 1 over 4 epsilon ZE square over R square. Now radius of the electron in nth orbit. You have to remember the formula. So Rn equals to n square s square epsilon pi m Z square E square. That is atomic number. Fine. So this relation you have to remember, that Rn is actually equal to n square over Z. Note down. Now radius of an electron in nth orbit. If it is hydrogen, you have to substitute that is equals to 1. But the Bohr's model is just applicable only in case of those atoms in which contains single electron. Note down fast, Alan, everyone. Done.
Yes, sir.
Now Bohr's radius of H atom means hydrogen atom. That equals to 1. This is known as Bohr's radius. Bohr's radius. Fine. So the radius of innermost orbit is known as Bohr's radius. Innermost means when n equals to 1. This relation you have to remember. Rn equals to 0.53 n square over z. Note down. Done. Done. Alan, Farhat, Namuna. Now these are the graphs. Variation of Rn. Rn equals to n square z times R1. R1 is the Bohr's radius. All right. This is R1 is 5, 3, and fine. If we have to plot the graph between z, atomic number versus the radius, it would be inversely proportional. And if I have to plot the graph, n means principal quantum number and r is, this is parabola, this is hyperbola, and Rn is directly proportional to n square, then it would be like straight line. Now, speed of electron in nth orbit. This formula you have to remember. This is most important. That v is directly proportional to z over n. Note down this formula and this one too. Done.
Yes, sir.
Now, in hydrogen atom for n equals to 1 means the innermost, H atom z equals to 1. This is the velocity. So this formula you have to remember 2.2 into 10⁻⁶ z over n. This formula also. Because if we change the atom, if we talk about lithium, then the velocity will change according to the orbit. These are the graphs. This is the velocity versus z, directly proportional. Velocity versus principal quantum number is inversely proportional. This is all. A time period. So this is a time period formula, n r and over k z e square. And since the Rn is directly proportional to n square over z, so to substitute the value of r here, you'll get time period is directly proportional to n cube over z square. And this is frequency. Frequency. These relations you have to remember. Try this question after this. Fast. 3 minutes. Fast. Try this question. Done. Write your answer in chat box. Fast. Alan, Mamuna, write your answer in chat box, everyone.
No, sir, can you show the fourth one also? Fourth option.
Half of its ground state radius. Fast. Now, when the hydrogen atom in its first excited state means n equals to 1, its radius is 4 times. What is first excited state? Look, ground state equals to 1, first excited state n equals to 2, then second means n equals to 3, and so on. Fine. So since I told you the relation that Rn is directly proportional, that is 0.53 Armstrong. Rn is directly, sorry, is equals to 0.53 Armstrong n square. Fine. So in first excited state means n equals to 2, 0.53 times 4 square. So in ground state, n equals to 1, that is 0.53. Now divide R2 over R1 equals to 0.53. So divide R2 over R1 is equals to, this is 2. So correct. It would be 4. Means R2 becomes 4 times of R1. Now A is the answer. A for R. Mavana, am I audible?
Yes, sir.
Did you get it?
Yes.
Now try this question. The radius of hydrogen atom. Fast. 4 minutes. Try this question fast. Fast. If you know the problem, the NEET questions are completely based on formula. 95%. B. Rest of you write your answer in chat box. Speed up. B. Very easy. Rest of you write your answer. Alan. Farhat. The radius of hydrogen atom in its ground state is given. That is Armstrong. After collision with an electron, it's found to have a radius. It's much of what is the principal quantum number? All right. So let it be Rn over R equals to 0.53 Rn equals to 21 point minus 10. This is equals to 5.3. R naught is given. And n square we have to calculate. This is 11, sorry. Cancel out. N square equals to 21 to over 5 over 3. 4. All right. Is it clear to everyone?
Yes, sir.
Okay, fine. Alan, what is the formula for, what is the relation, what is the formula to calculate the velocity of an electron?
So can you repeat the question?
What is the formula to calculate the velocity?
So of
Of an electron move in nth orbit of an atom having atomic number Z. Just let me know the relation, that's it. That V is directly proportional to
so it's directly proportional to Z and inversely proportional to N.
okay. Mamuna,
Yes, sir.
to explain his theory, Bohr, fine, used which of the option is correct? Conservation of linear momentum, conservation of energy, conservation of quantum frequency, or conservation of energy. Sorry, conservation of linear momentum, conservation of angular momentum, conservation of energy, or the frequency condition, quantization of frequency condition. Which of the option is correct?
Conservation of energy.
Farhat, to explain his theory, Bohr used conservation of angular momentum, conservation of linear momentum, conservation of energy, or the quantization frequency.
Angular momentum.
Yeah, an electron always moves in that orbit, which is the integral multiple of, in which the angular momentum is an integral multiple of h by 2 pi. So when an electron moves around the nucleus, it has some velocity, so must possess it must possess kinetic energy. So kinetic energy equals to, note down the formulas. The R is the Rydberg constant, H is Planck constant, C is the speed of light, Z is the atomic number of the atom, and N is the principal quantum number. This is Rydberg constant, 1.09 10^7 per meter. Note down. We can see the kinetic energy is Z square over N square. Note down fast. Done. Now potential energy. So if there are two charges, nucleus positively charged and electron is negatively charged. So potential energy equals to 1 over 4 epsilon. What is the potential energy? K Q1 Q2 over R. R is the distance between the two charges. So UN, potential energy in the nth orbit equals to -1 over 4 epsilon Ze square. Z is the charge on nucleus and E is the charge on electron over Rn. Rn is the distance from the center of the nucleus. So Rn is n square h square epsilon pi m square Z square. Now substitute the value of n. You'll get this is a potential energy. Note down the formula. So electrostatic potential energy is this. And this is the final. You can say Z is also directly proportional to Z square over n square potential energy. Fast.
So what is after H?
Tz square over n square. Done.
Yes, sir.
Now total energy is kinetic energy plus potential energy. If you sum up, you'll get this is the total energy. This is the total energy. This formula you have to remember. There must be just a number. Z square also. So EM is also like your open to Z square. Note down this formula. Done.
1 minute, sir. Yes, sir, done.
Potential energy is negative 2 times of kinetic energy. This is UN. These relations you have to remember. These relations will help you in solving the questions. Very easy. Means you'll find the questions very easy. Just note down. Potential energy is negative 2 times of kinetic energy. The magnitude of potential energy 2 times of kinetic energy, and the total energy is negative of kinetic energy. Done.
Yes, sir.
Now, an electron volt, this is Redox constant. H, the product of R H C is 13.6 electron volt. For hydrogen atom, that equals to 1. So this is the energy. 13.6 over n square. It is an electron volt. So let an electron jumps from n1 to n2. The change in energy is En2 minus En1 Z m e raised to power 4 8 epsilon square h square. This n1 is the n1 n2 both are the orbits. Electron jumps from n1 to n2, in which n2 is greater than n1. If you simplify, so this is change in energy. What is change in energy? Sc over lambda. Because if an electron jumps from higher to lower, then it emits energy in the form of photon, whereas when it jumps from lower to higher, then it gains energy. So when it jumps from n2 to n1, so it emits energy in the form of photon. So energy Sc over lambda, this is the formula, that is square m e4 a epsilon h square, this h square. All right, fine. N1 minus n2. If you move Sc in the denominator, so this thing is Redox constant, that is R. So you have to remember this formula. Note down this formula. 1 over lambda is the wavelength, that is the atomic number, R is the input constant, and when n2 are the orbits, principal quantum number. Done. Everyone done?
1 minute, sir.
Done. Wave number is 1 over lambda. You have to remember this formula also. Note down fast. Everyone. Done. Now try this question. The total energy of an electron in an atom is this. Its kinetic energy. You have to use the relation. The total energy is given minus 13.4 minus 3.4 electron volt. Calculate kinetic energy and potential energy. First, use the relations. One is total energy is negative times of kinetic energy. Use the relation first. And potential energy is 2 times of kinetic energy. Write your answer in chat box, everyone. Fast. Write your answer in chat box, everyone. Fast. Done. B. Farhat, write your answer, please. Maimuna, write your answer. Hanifa, Hiba. Everyone, please write your answer. Farhat, B. Hanifa. Very easy question. So what is kinetic energy? Kinetic energy is negative of minus E, that is equals to 3.4 electron volt, and potential energy, that is U, is 2 into 3.4 minus 6.8 electron volt. B is the answer. Now try this question. If an electron hydrogen atom jumps from the third orbit to the second orbit, then it emits a photon of wavelength lambda. When it jumps from fourth orbit to third orbit, the corresponding wavelength. Fast. 3 minutes. Try this question and write your answer in chat box, everyone. Write your answer in chat box fast. This formula we have to use it. Everyone, please write your answer in chat box. Please write your answer. Farhat, Saifullah, Alan, Maimuna, Hiba, Hanifa, write your answer. B, Maimuna, B. Rest of you write your answer fast. So what is lambda? Lambda, let it be lambda 1. C. What is Z? Hydrogen atom Z is 1. So R equals to, if an electron in a hydrogen atom jumps from third orbit to second orbit. So jumps from N2 to N1. What is N1? Alan, what is N1?
So 3.
And what is N2?
So 2.
Now what 9 over 4, that is equals to R minus 5 over 4 times 9. Next, likewise 1 over lambda 2 equals to R. Now in this, what is N1? What is N1, Mamuna? It jumps from fourth orbit to third orbit. What is N1?
3.
3. Alan, 3.
So 2 and 3.
Should be four and 3. It would be 9 minus 16 over 16 times 9. It would be minus 7R over 9. Now, let it be second, and this is first. We have to calculate the ratio. No, lambda 2. Okay, lambda is given. So 1 over 2. Lambda 2, 1 over lambda 1. That is equals to minus 7R for 16 times 9. Plus 5R 4 times 9. 9 will cancel out. R will cancel out. 4. 7 over 20. Lambda 1 over lambda 2. So lambda 2, sorry. So lambda 2 equals to 20 over 7 times lambda. All right. C is the answer. is the answer. Mamna was correct. Aaron also. Mamna, sorry. Mamna was wrong. Farhad also. This is the way to do this question. Now further. Hydrogen spectrum. It consists of discrete bright lines in a dark background known as hydrogen emission spectrum. But series limit like Balmer, like Lyman, Balmer, Bastian, Piffin, bracket, these are series limit. So the transition corresponding to maximum energy. Just remember one thing, energy is proportional to lambda. So the transition corresponding to the minimum energy and maximum energy and minimum wavelength is called hydrogen. It's called the hydrogen spectrum of hydrogen spectrum is called series limit. So this is for Lyman. Lyman for N1 for Lyman N1 equals to 1. For Balmer N1 equals to 2. For Bastian for P1 likewise. In general, just remember 1 over lambda equals to R square over N square. So hydrogen spectrum, a discrete bright light in dark background. Series limit, the transition corresponding to maximum energy and minimum wavelength. For Lyman, N1 equals to 1. For Balmer, N1 equals to 2. This is the Rydberg constant 1 over lambda over N square. Just remember one thing. Look, if we have to calculate the longest wavelength, fine. If we have to calculate the longest wavelength, indirectly that lambda is directly proportional to the quantum number. All right. Now try this question. Ratio of longest wavelength corresponding to Lyman and Balmer in hydrogen spectrum. If the energy is minimum, the wavelength is longest. Fast. Try this question, write your answer. This formula means 1 over lambda, you have to use it. One over lambda are hydrogen atom. Hydrogen Z is 1. So N1 square minus N2 square. Now the wavelength is longest. Write your answer in chat box, everyone, fast. Lambda equals to, how will you write? 1 over R N1 square minus N2 square. Okay. A. Rest of you write your answer fast. For longest wavelength, this must be minimum. For Lyman, N1 equals to 1. For Balmer, N1 equals to 2. Passion N1 equals to 3. Fast. Alan, write your answer. Farhat, write your answer. Mamuna, write your answer fast. The ratio we have to calculate. For Lyman is to Warmer. For Lyman, lambda L equals to 1 over R, and 1 is 1. This is 1 minus 1 by 4 equals to R. It would be 3 over 4. That is equals to 4 over 3R. Likewise, for Balmer, N1 equals to 2. That is R. 1 over 4 minus 9. So it would be 9 minus 4 is 5. 5R. 9 4 36. If you divide, Lyman is 4 over 3R, 36 over 5R, RR will cancel out. Four times 5, 36 into 3, 9, 5 over 27. So just remember one thing, whenever we have to calculate the longest wavelength, it means we have to jump from 1 to 2. And if we have to calculate the shortest wavelength, then N2 we have to take it infinity. Okay. If we take infinity, then the wavelength will be minimum. All right, because lambda is equivalent to the principal quantum number. Fine. So in this, the question was asking the longest wavelength. It means from 1 to 2. In case of Lyman, fine. If the question was asking if it has asked that calculate the ratio of the shortest wavelength corresponding to Lyman and Warmer series, it means N2 we have to take it in both the cases infinity. Now try this question, everyone. Very easy question. 3 minutes. Write your answer in chat box fast. The energy of hydrogen atom in a ground state is this. The energy of helium ion in the first excited state. Energy we have to calculate. Now which formula we have to use it, Alan? In this question, Farhat.
So the EN formula.
En equals to minus 13.6 Z square over
N
N
square.
What is that for helium?
So both are 4.
Minus 13.6 electron volt. It must be okay. This formula we have to use it. First excited state equals to 1. Mamuna, if I say third excited state, then N equals to What do you mean by third excited state? Mamuna, n equals to, what is the principal quantum number? What is the principal quantum number? Farhat, what is the principal quantum number for third excited state?
4.
Sorry.
4.
Okay. What is quantum number? What is the principal quantum number for ground state, Saifullah?
Sir, can you repeat again?
What is the principal quantum number for ground state?
1.
Okay. Now, excitation energy, these are the definitions. The energy required to take atom from its lower energy state to higher. Like by excitation potential, also the potential through which electron should be accelerated to gain higher state. Ionization potential, ionization energy, the energy required to ionize an atom. It means how much energy is given to an electron so that it escape out from the atom. That is ionization energy. Ionization potential, the potential difference for which an acceleration should be accelerated to get ionization energy. So this is an ionization energy 13.6 Z. That is the atomic number. This, I think it was Z. And this is ionization potential, ionization energy over E. That is 13.6 Z square over N square. Z is the atomic number and N is the principal quantum number. Binding energy. So potential energy is negative and the total energy is negative. So what does it imply? Negative means the force is attractive. So binding energy means the energy required to separate the constituent of a nucleus to infinity. It means how much energy is provided to the given electron so that it escape out from the electrostatic, it escape out from the orbit. That is known as binding energy. So binding energy in ground state of hydrogen atom is 13.6 electron volt. Look, if I say calculate the energy, binding energy in case of binding energy, it must be positive. Fine. What is the binding energy in first excited state, Alan? This formula we have to use it to calculate the binding energy. 13. This is an ionization energy, sorry. So this formula, first excited state. What is the binding energy in second excited state? Alan, what is binding energy in second excited state? So 13.6 over second means and is 3 in case of hydrogen atom. Second excited state. Hello, Alan.
Yes, sir.
This is the way to calculate the binding energy. If I say second excited state, it means n equals to 3. First excited state, n equals to 2. Fourth excited state, then n equals to 5. Okay. Now try this question. Energy of an hydrogen atom with the principal quantum number n is given by. Try. I just come in a minute. Hello, am I audible? Done. Write your answer in chat box, everyone. Fast. D. The energy photon ejected when the electron jumps from n free state to n. D. Okay. Rest of you write your answer in chat box at least. Whether it is wrong or right, please write your answer in chat box. Farhat, please write your answer. Hiba, Hanifa, write your answer. Please write your answer in chat box. Okay, Alan, how to do?
I
Alan,
subtract the
first
E
look
values.
how to initiate. We will calculate, let it be E3 second excited state, that is minus 13.6 for hydrogen atom.
By 3 square.
9. Okay. If I divide it, how much will I get?
So I found E2 and then did the fractional thing
Okay.
first.
E2 is minus 13.6 over 2 square.
By 4.
Okay.
Yes.
Yeah, by 4. Now, next. So delta E will be the energy of photon ejected when the electron jumps from 3 to yes. Now this is final energy. I have to do.
I had a 13.6 by 1 by 4 minus 1 by 9.
That's fine. 13.6.
So 1 by 4 minus 1 by 9, right?
Now subtract it. It would be 36 over 5.
That would be 0.12.
0.
So 5 by 36 is 0.12.
0.12.
So 5 by 36, 0.12 into 13.6.
Okay, okay. 0.12 into 13.6. And if you multiply, then you'll get 1.9.
Yes, sir.
No, correct answer. So let's calculate it. Simple question, substitute in the formula. A spectrum. Absorption spectrum means this is an atom. So if an atom absorbs a photon, so electron get excited and it jumps to a higher energy state. Fine. So let it be En1 is the energy in lower state, H nu is the energy of a photon equals to En2. Fine. After 10⁻⁸ seconds. Fine. This is the spectrum for this is absorption spectrum. Fine. As the electron absorbs the energy, as the atoms absorb the energy, its electron get excited and it jumps to n equals to 3. Third energy level. Then this is spectrum. Fine. After 10⁻⁸ seconds, it emits and comes back to n equals to 1 energy level. Fine. So there are two spectral lines. How many ways? Either goes 3 to 2 and 2 to 1. Or 3 to 1. So how many spectral lines? There are 3 spectral lines. 1, 2, 3. Now to calculate it, did you get it? When this is absorption spectrum, if an atom gains potential and if an atom absorbs a photon, then its electron gets excited and jumps to higher energy state. This is absorption spectrum. After some time, that is 10 to the minus 8 seconds, it emits and it comes back to it emits energy in the form of photon, and it comes back to n equals to 1 energy level. So there are 3 ways, either 3 to 2, then 2 to 1, or 3 to 1. Okay, so there are 3 spectral lines. This is the formula to calculate the spectral line. So n bracket n minus 1 over 2. Okay, this formula you have to remember to calculate the number of lines emitted. Understood, Farhat? Alan, did you get it?
Yes, sir.
And now try this question, very easy. The hydrogen atoms are excited from ground state of principal quantum number n, where small n is principal quantum number, and the number of spectral lines. Fast, write your answer in chat box, everyone, fast. Write your answer in chat box.
Sir, can you show the formulas, please?
This is the formula that we have to use it. And n minus 1 over 2. Fast. Write your answer in chat box. D. So n equals to 4, 4 minus 1 over 2. B is the answer. Now try this. To explain his theory, Bohr used which of the option is correct? Rest of you write your answer in chat box fast. Which of the option is correct? Conservation of linear momentum, conservation of angular momentum. Eva, am I audible to you? Hanifa, could you please write your answer in chat box? Why are you not responding, Eva and Hanifa? At least write your answer in chat box. B is the correct option. Okay, try this question before that. When electron jumps from n4 equals to n2 orbit, then second line of Lyman series, second line of Balmer series. Which of the option is correct? Fast. Fast, everyone write your answer. Which of the option is correct? Alan, write your answer. When it jumps from n4 to n2, that is Balmer series, second line of Balmer series. All right. This one, last question. Hydrogen atom ground state is excited by hydrogen atom. Lambda is given, number of spectral lines we have to calculate. Write your answer. Write your answer, everyone. Please write your answer. Please write your answer, everyone. First of all, we will calculate the energy. Fast. See. How will you approach Alan this question? Just let me know the approach.
So I'm still doing this one.
Sorry,
I'm still doing this one question.
you're not getting this question. Will you be able to do this question, anyone? Do at home and let me know tomorrow. Energy formula, we have to use it. First of all, we will calculate the principal quantum number. Okay. Take a screenshot and tomorrow we will discuss. Fast. Done. Bye. We will discuss this question tomorrow.